Back to Further Solutions Academy. Further Solutions Academy. Encourage us more to share and also subscribe. If you have not subscribed before, press on your subscribe button before on after. And presently we have over 300 videos on our platform. It means you can come here and learn any topic of your choice: mathematics, physics, and chemistry. Now, if you have any topic, like you are expecting a topic that is not yet available on this platform, you can check on us, which is drop email below, or you reach us with this number. Now, with this line, you can do three things with this. You can call us, you can WhatsApp us, and via Telegram is allowed. Either of the three, you are allowed to do. Okay, and also if you want to make any contribution, any platform, I think we need to buy a bigger board and better camera and so on and so forth. You can contribute by reaching us with this line, which our account number will be sent to you. Now, we have this topic at hand, which is by the end of this topic, by the end of this video, we may not be able to cover everything, but these are the outline, what we have for you on this part, which is projectile. Now, the first one we'll talk about definition of projectile. The second will be forms of calculating projectiles, and change with time, which is how do we change it, resultant projectile, and problems on this problem can take another video or more. I have to show you different ways of solving projectile in any given exam. Now, I have this. Let's start from the beginning, which is talking about projectile. Now, when we talk about projectile, we are talking about motion, which is there will be a force, which is we have to throw it. You are throwing a body, you are throwing an object, which it's always in form of this way. Mr. A can be here throwing a what? Now, this is what, do you get me right? And it will surely land. Do you get me now? It means there must be a force, you throw it, there must be height, and there must be a what? Range, from the beginning to the end. We have to understand those things. That is what I have for you on this video. Now, we have time that these objects used to fly from the beginning to the end, and the maximum height, and we have what is called the range, which is range from here to here, and so on and so on. We have also there will be velocity. There must be a velocity, and so on and so forth. Acceleration also will be there. That is what we want to work on as far as this video is concerned. Now, let me quickly write something on projectile. When we talk about projectile, we are talking about a projectile is any object thrown or released into space that travel along a curve or parabolic path. Now, that is what we know. That is what we should know about projectile. Now, we have done parabolic, which is, you should know, when I was talking about linear, parabolic, and eclipse, equation of conic section. Please, you have to understand on straight, which is an arc. Now, when we are throwing a subject, which you throw something up, and that thing move along on a curve or parabolic path, that is being known as what? Projectile. Now, okay, when we move on, let's move on with this definition. It means it has. Okay, let me quickly explain the characteristics of this thing. Now, if we're looking at characteristics of projectile, vertical components and horizontal components are very, very important. Now, it's characterized into let me use the word horizontal motion at constant velocity, where linear acceleration, this is acceleration, which is a equals to 0 meter per second squared. That is number one. A1, and also two, vertical motion, which is upward or downward, with constant acceleration, where gravitational acceleration, which is G, equals to, normally we have supposed to be 9.8 meter per second squared, but most textbooks use 10 meter per second squared. Anyhow it is, but know that in your mind that it's 10 meter per second squared. Now that is what you need to know about that. That's what you need to know about that. Now the second thing we need to know is that which is, I'll call it B. Let's talk about B now, which is we are talking about object projected horizontally. Now object projected horizontally. Object projected horizontally forms a what? A height forms a height. Now, how do I use that? It means this can be a what? A building, the top of a building. One man is standing there, which is throwing something down. Now, that is what I mean by that. Now, it means this is the height, which is here we know it as height. Why this one is known as what? We can call it vertical part of it, which here we call it horizontal, which is, you all know as horizontal. Now, what happened here? The first thing you need to know is that this can be here, it will be here, and it will be here, it will be here. Now, when that thing is coming down, the first thing we need to know is that this one will be U, this is U, this is V. Now, U is V. Now, this is, we all know as U is always called initial velocity. You know that. And my V is final velocity, which is my V. It's just like arrow. This is my V. Now, which is my final velocity. Now, we have my U. And this will be what? V. This is going to be U. This is going to be. And this is going to be V. This is going to be U. Now, what I'm trying to do there is that we have V1, V2, This one can be V1, V2, V3, and so on and so forth. Now, what I'm trying to say there is that note the initial, which is known as U, horizontal velocity U does not change. Does not change. It remains constant during the duration or time. I can use the word duration or time of motion. During or duration of what? I mean during the time of motion or duration of motion. Now, the initial vertical velocity, which is v equals to 0, however, vertical velocity, okay, now velocity, which is of velocities, we are talking about velocity which is v1, v2 to v, okay, you have v3. It can be more than that to v of n, which is vn. Change with time. Change with time. Now, that is what you need to understand about this. Very, very important. Change with respect of what? Of time. Now, with this, let's move on to the equation of uniform acceleration. Equation of uniform acceleration of projectile. Equation of uniform acceleration of projectile. Now, when we talk about equation of uniform or uniformly acceleration or accelerated, let me use the word accelerated motion. Now, which are always like we all know equation of motion, which is there are three of them, three equations of motion, which is from Isaac Newton's law. Now we have it in form of u equals to u plus v equals to u plus at, which is 1, and v squared equals to u squared plus 2ax, and the last one will be x equals to ut plus 1 all over 2 at squared. Now, at this point, talking about in form of acceleration, I mean in form of projectile, because at this point we are referring to what? Gravitational, which is gravity. We are related to gravity. It means this G, this A will turn to what? To G. It will turn to what? To G. Please take note of that. They are very, very important. Now, let's move on to object projected. Object projected at an angle theta to the horizontal to the horizontal. Now, when we are talking about angle, at this point we have it this way. Now we have it, this will be y, which is also x, vertical and horizontal, vertical and horizontal. Now we have something like this. Let me create this to something. Now we have it this way. Now the angle we are talking about, this should be my velocity. I'm not getting very well. This should be my velocity, which we'll be talking about u. Now, this part we call it, when you resolve it, we have it u sine theta. Now, where here will be the theta? Why here will be u cos theta? And what is here is, this is going to be u. We have it this way, we have it this way, and we have it this way. Let me have it this way. Now this one will be what? V of, and V of what? Of x. It means component. I'm just referring to the component part of it. This one will be what? V of x. This one will be V of x, V of y. Now let me have another one like this, which is the, it means I'll be having one of them, 1, 2, 3, 4, which is 4 point of it. Now at this point, this is called h, which is called height. That is called height. That is called height. Now that is what this is all about. That is what this is all about. You can read more on them and gather more information on this part, but this is what we are trying to work on at this point. Now, before we move further, let me quickly explain the result part, resultant of projectile, or how do we result it? Resultant of it. Now, when we have it this way, let me quickly put a resultant projectile. Now, we have it this way. V of x, V of y. This is the what? The resultant. Sorry. Now, we have it this way. Now, it means we are talking about V of x, and this one will be V of y. Anyhow it is. Now, note something. This is the resultant, which is V. During upward, this is during upward motion. Why this one is what? During downward motion. Now, during downward motion. What I want you to know here is that with the help of this, it obeys Pythagorean theorem, which is Pythagorean rules. It obeys Pythagorean rules. Since it obeys Pythagorean rules, which is using Pythagorean theorem. Pythagorean. We all know what is called Pythagorean theorem from our mathematics, or our simple mathematics. Sorry. Which it means my v squared equals to v of x squared plus v of y squared. That is what is called Pythagorean theorem. Now it means my v equals to root of v of x squared plus v of y squared. That is Pythagorean theorem. Now this v, we call it resultant. We call it resultant. That is my resultant. Now that is my resultant. Now if I want to find the angle, my angle, we are with help of this, which is a SOHCAHTOA. If I form a angle here, it means I'm talking about what? Tan theta equals to opposite all over adjacent. Opposite all over adjacent. It means I'll be having V of y all over V of x, which my theta will be equals to tan inverse of V of y all over V of x. V of y all over V of x. By so doing that, I've already gotten my V of x and y. I mean, what's it? My angle forms. Now, let me move on to the next one before we go to the calculation part of it. Okay, let's move on to projectile in motion. Now, the first thing we need to know is that time to reach the maximum height. Time to reach the maximum height, which is a time taking to reach maximum height. It means my t equals to u of sine theta all over what? Of g. There is proof for it, but I may not be able to prove it for you now. I don't have the time. Now, the next one, time of flying. Time of flight, which is, I call it capital letter T. This is small letter C, this is capital letter T. It means it will be 2 of theta sine theta divided by g. 2 of theta sine theta divided by what? G. And the next one we'll be talking about maximum height. Maximum height. Okay, maximum height. Maximum height, which is going to be h. H equals to u squared sine theta squared divided by 2g. Or you can have it this way: u squared sine theta bracket of r squared divided by 2g. Either of the two. With the help of trick, you will understand better this part. Now, the last one we'll be talking about horizontal range, which is, we call it r. We always put it r equals to u squared sine theta, mean 2 theta rather, 2 theta divided by g. Now, that is all about that. That is all about that. I won't go more than this on this part. But before I end this video, let me quickly show a simple question that will really help us. I have a question here that will really help us to understand this part very well. Let me quickly rush over it. Okay. Okay. I have this question. An arrow is horizontally projected from the top of a tower with an initial velocity of 15 meters per second. If it reaches ground 7 seconds late, calculate the height of the tower, taking your G 10 meters per second squared. Now look at this question, solution to this problem, just to to explain all what I've been saying since. Now what I need to know there is that we have my T, which is my time, will be 7 seconds. My G also is given as 10 meters per second squared. And what else? My U is 0 meter per second. My U is 0 meter per second, which is my initial velocity. Now, what I will just think of, I'm looking for the what? Height. Now, it means equation of motion under gravity, which is my h equals to ut plus 1 all over 2 gt squared. Now, my h, the same thing as my s, my g, it means I'm working towards what? Gravity, which is under gravity. It means I can answer that. Note something, note, this is very important information that you need to understand the technical part of this question. Look at this 15 meters per second are given in the question. In the question was not used as the initial velocity. Was not used as initial velocity because 15 meters per second represent the initial horizontal velocity and not the initial vertical velocity. Not now, it means what I will just do is that my h equals to ut plus 1 all over 2 gt squared. Now that's what I mean. It means my h it will equals to 0 multiplied by 7 plus 1 all over 2 multiplied by 10 multiplied by 7 squared, which I'll be having this equals to 5 multiplied by 49. Now 5 multiplied by 49, which I'll be having my age, it will be equals to 5 times 4, that'll be 20 and 9, which is going to be 2459, which is meter. That is my answer. That is all about that. Now, don't forget you are on with Further Solutions Academy. Further Solutions Academy. Encourage us more to share. Anywhere you see our video, just encourage us to share it to your friend. And if you have not subscribed, don't just watch without subscribe. Please make sure you subscribe to it. Just press the subscribe button. And if you want any updates, you want to update us anything, you can reach us with this line 2348034495990. With this line, you can call us, you can WhatsApp us, and Telegram is allowed. Once again, thanks for watching.